Matrices. You can define a matrix. Matrix is a rectangular array of numbers whose value and positioning in the matrix is significant. Particularly when you're multiplying or adding or just operating matrices, the arrangement of the matrix is quite important, the way it is arranged. Matrix is usually, but not always, shown in bracket. E.g., 1837. The size of a matrix is given by the number of rows the matrix contains and the number of columns. This one is a 2 by 2, 2 rows and 2 columns. So it is called a 2 by 2 matrix. One is, it has 3 rows and 2 columns. It is called a 3 by 2 matrix. By, not times. One is called a 2 by 3 matrix. This one is what size? This one here. 3 by 3. So the naming of the matrices is important because you find that the determination of some of the operations, arithmetic operations on the matrices depends on their sizes. The standard notation for an element in a matrix is given by Xij, implying that the element in row I and column J. So we have relationships between matrices and vectors. In this course, we look at vectors too. So we need to relate vectors to matrices. A single row matrix is called a row vector. Single meaning it has only one row. And a single column matrix is called column vector. Example, this one is called a row vector. This one is called column vector. Look at matrix algebra. So matrices are always referred to using capital letters. Matrix A. Matrix addition. So when we are adding matrices, the rule is you can only add matrices which have the same sizes. matrix addition, the corresponding elements in the matrices. That is why they are supposed to have the same sizes. So A plus B, what is the size of A? What is the size of matrix A? What is the size of matrix A? Two by three. So A is a 2 by 3 matrix. B is the size of matrix B. What is the size of matrix B? Two by three. So that is why we can add them because they are of the same sizes. We add corresponding elements 1 plus 2, 11 plus 0, 2 plus 3, 6 plus 9. That is 3, 9, 9. Can you find B plus A? What is B plus A? What is B plus A? What do you get? I want to see what you get. 3, 11, 9, 11, 11, 15. So it is the same thing. Sorry. Plus 1 is 2 plus 1 is what? Two plus 1? Just answer. Not prevented you guys from answering. 2 plus 1 is what?
The answer is 3.
Yeah. 0 plus 11?
11.
11. 7 plus 2?
9.
5 plus 6?
11.
9 plus 2?
11.
6 plus 9?
15.
Hmm?
15.
6 plus 9 is what?
15.
So what is the relationship between A plus B and B plus A? What is the relationship between A plus B and B plus A?
They're equal.
They are equal.
They're equal.
Equal. They are equal. When we look at matrix subtraction, we're using the same thing. A minus B with 1, 11, 2. One minus 2, 1 minus 2. Members, can you just say it? What is 1 minus 2? 1
Minus 1.
11 minus 0,
11.
2 minus 7,
Minus 5.
6 minus 5,
1.
2 minus 9,
Minus 7.
2 minus, sorry, 9 minus 6,
3.
Kate, what are you doing in my document? B minus A. Can you get B minus A? The same way. What do we get? B minus A gives us what? What is the answer here for B minus A?
1,
Mhm.
negative 11,
Right.
5,
Mhm.
7, negative 3.
So 2 minus 1 is 1. 0 minus 11 is minus 11. 7 minus 2 is 5. 5 minus 6 is minus 1. 9 minus 2 is 7. 6 minus 9 is minus 3. What is the relationship between A minus B and B minus A?
A minus B is equal to negative B minus A.
So that is true. That is one. Another one? Other than that, what
A
else?
minus B is not equal to
It is not equal. So we look at matrix multiplication. Scalar multiplication. Let A be equal to OA. What is the scalar? Just multiply all the elements in that matrix by 4. So we look at matrix multiplication. So there is a rule here. Two matrices can be multiplied if number of columns the first matrix is equal to the number of rows of the second matrix. Let A be so what is the order of matrix A? What is the order of matrix A?
3 by 2.
3 rows and 2 columns. What is the order of matrix B?
2 by 4.
So you can see that is equal. Whenever that is the same, you can multiply them. The column of the first matrix and the row of the second matrix are equal. Then this one gives you the order of the matrix. The product matrix. The C will be a 3 by 4 matrix, meaning you'll have 3 rows, C1, C1, C is a product.
Oh. Eh. Ah, na nani kwa chile kwa demo do mere. Eh. Ai. Ai kwa ma na ka ku ye shura. Ai kwa nani ku ma ka nani di mare. Ora, ya una do mere ka ke man ku do ma ti ra do.
3, 2, 1, 2, 2, 3. So with this can tell you how to multiply. Sometimes if you have forgotten how to multiply, you can always write the product matrix. This is how we write this matrix. And this will tell you what to multiply. You're multiplying row 1 by column 1, row 1 by column 2, row 1 by column 3, row 1 of this by column 1 to give you this, one of that by column 2 to give you that one, row 1 of this by column 3, row 1, column 4. So that tells you what your product will be. And so once you write the elements in that matrix, it can tell you how to multiply. A. Yes, A is 3 by 2. That's why you can see they can multiply. 3 rows and 2 columns. And this one is 2 rows, 4 columns. That's why you can see they can multiply. So let us look at an example. AB will be equal to 3 times 8 plus 1 times 3. Row 1, column 1. 3 times 0 plus 1 times 2. Row 1, column 2. That's what this product matrix is telling us. Row 1, column 2. Then you have 3 times 5 plus 1 times 11. Then the last one is 3 times 4 plus 1 times 1. Then row 2, column 1, 2, 1, 2 times 8 plus 4 times 3. Row 2, column 2, 2, 2. Four times 3, and then we have 2 times 0 plus 4 times 2, 2 times 5 plus 4 times 11, 2 times 4 plus 4 times 1. Then the last one, you have 3 by 1, 7 times 8 plus 4 times 3, 7 times 0 plus 4 times 2, 7 times 5 plus 4 times 11, 7 times 4 plus 4 times 1. So these ones, if we multiply and add, remember I'm just taking us to the basics so that we know what to do. 3 times 8 is what? What is 3 times 8?
24.
24. 1 times 3.
3.
3 times 0.
0.
1 times 2.
2.
3 times 5.
15.
1 times 11.
11.
3 times 4.
12.
1 times 1.
1.
2 times 8.
16.
4 times 3.
12.
2 times 0.
0.
4 times 2.
8.
2 times 5.
10.
4 times 11.
44.
2 times 4.
8.
4 times 1.
4.
7 times 8.
56.
4 times 3.
12.
7 times 0.
0.
4 times 2.
8.
7 times 5.
35.
4 times 11.
44.
7 times 4.
28.
4 times 1.
4.
So you need to do a lot of practice. If you know how to multiply matrices, you know how to do everything in this course because it rotates around matrices and vectors. You have seen that a vector is a matrix, a column, row or column, or a row, column matrix or a row matrix. 24 plus 3. What is 24 plus 3?
27.
0 plus 2.
2.
15 plus 11.
26.
12 plus 1.
13.
16 plus 12.
28.
0 plus 8.
8.
10 plus 44.
54.
8 plus 2.
12.
6 plus 12.
68.
0 plus 8.
8.
35 plus 44.
79.
28 plus 4.
32.
That is what you get. Can you try this one? Can you correct that? What do you get? What is AB? AB. What is AB? AB. What is AB? It's 290. That's correct. Normally we check first. This is a 1 by 3. This one is a 3 by 2. So find that because of those two, you can multiply. And your products matrix is 1 by 2 matrix. 1 row, 2 columns. That's why you have seen 82, 90. 1 row, 2 columns. That is equal to 5 times 4 plus 6 times 1 plus 7 times 8. Then you have 5 times 3 plus times 2 plus 7 times 9. So that is 20 6 plus 6 10 plus 12 plus any question up to then? A zero matrix is a square matrix. Those elements are all zeros. Any matrix you're multiplying with a zero matrix, you get zero. Zero matrix. Matrix multiplied by a zero matrix is equal to a zero matrix. Unit matrix is any square matrix whose whose leading diagonal elements are ones. And the other elements are zero. E.g., 1, 0, 0, 1, or 1, 0, 0, 0, 0, 1, or 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1. A matrix A times these are called identity matrices. A matrix times its identity is just equal to that matrix. Matrix times an identity matrix is equals to that. Let A be 1, 6, 2, 3. A and equal to 1 times 1 plus 6 times 0 will give us 1 times 1 is 1, 6 times 0 is just 0. 1 times 0 is 0, 6 times 1 is 6, 2 times 1 is 2, plus 3 times 0 is 0. 2 times 0 is 0, plus 3 times 1, which is, so you just get A, what you say, A times, just giving you. Matrix times its inverse will give you an identity matrix. Identity matrix, the one we have seen, the matrix times its inverse will just give you an identity. So let us see how to get the inverse of. We've already learned at ACC how to get the inverse of a 2 by 2 matrix using the determinant. But we will start by looking at the row reduction, which we have not done, and then we look at the determinant. Um, So we know that a matrix times its inverse will give you an identity matrix. So to get the inverse of a matrix, we always multiply it by the identity matrix. And then reduce this matrix to this identity matrix. What reduces this matrix to that identity matrix is its inverse. So as you reduce this to this, what you get here is the inverse of that matrix. We want to reduce that one to 1, 0, 0, 1. In the process, we'll be getting what is reducing it to 1, 0, 0, 1, which is its inverse. because the matrix times its inverse gives you an identity matrix. So when we are using row reduction, already we have one. So we will make this one 0. And as we make this 0, we make everything on that row. It affects everything. So we'll have to make this 0, we will take row 2 minus 3 row 1. So you look at what you want to get 0. How do you use row 1, 2, and row 2 to make that one 0? Sometimes there are 3 rows. Sometimes it is a matrix in 3 unknown. So you can use 1 and the second one, row 2 and the third one, depending on what can reduce it. So row 2 minus 3 row 1. Row 2 is this one, 3 minus 3 row 1. 3 times 1 is 3. So 3 minus 3 will just give us 0. But you do the same for also these ones. So that row 2 here is 4. Minus 3 times 2 is minus 6. 4 minus 6 will give us what value? 4 minus 6 will give us what value? Members, 4 minus 6, what do you get? Can you just say that 4 minus 6 tunapata nini? Ama mko wapi huko mnaandika? 4 minus 6, what do you get? Minus 2. Row 2 here is 0. 0 minus 3, you get minus 3. Row 2 here is 1. 1 minus 3 times 0, we get 1. So we are using rows 2. That's why it's called row reduction. We're using row 2 and row 1 to make this 0. We want to make this 1. So to make this 1, once we get it, we just divide it by row 2 divided by minus 2. 0 divided by minus 2 will give us 0 in that row. Minus 2 divided by minus 2 will give us 1. Minus 3 divided by minus 2 will give us 3 over 2. 1 divided by minus 2 will give us 1 over 2. We want to make this one 0. So we want to make this one 0. We will take row 1 minus 2, row 2. So make sure that this does not change when you're looking at what to do. That's why we came down here. Once you make this one 1, it's very easy to change that one. We took that direction. Because here you have R1 is just, you are careful that you don't change that. When you have 0 and 1 here, you do not change them. These ones will remain because we've already gotten 0 and 1. R1 minus 2 R2. R1 here is 1. Minus 2 times 0 is just 0, so you have your 1 there. R1 here is 2. Minus 2 R2. 2 minus 2 times 1 is 2. So 2 minus 2 is 0. R1 here is 1. 1 minus 2 times that. 1 minus 2 times this is 3. 1 minus 3 is minus 2. R1 here is 0. 0 minus 2 times 0 minus 2 times R2. 2 times this is 1. So 0 minus that is just 1. So you have got the inverse. And you can prove that that is the inverse. Because we know that matrix times its inverse gives us an identity matrix. We just multiply the matrix and that inverse and see whether it will give you an identity matrix. Can you multiply this and find out whether it will give us an identity matrix? The identity matrix is 1, 0, 0, 1. What do you get? 1 times minus 2 is minus 2. 2 times 3 over 2 is 3. So minus 2 plus 3 is just 1. 1 times 1 is 1. Minus 2 times 1 times 1 is 1. Plus 2 times this. 1 times 1 is 1 plus 2 times that. 2 times this will give you minus 1. So minus 1 plus 1 times 1 is 1 plus 2 times this is minus 1. So 1 plus minus 1 is 0. 3 times that is minus 6 plus 4 times that. 4 times this is 6 minus 6 plus 6 gives you 0. 3 times 1 is 3 plus 4 times this is minus 2. 3 plus minus 2 just gives you. So once you get this, you know that this is the inverse of that one, because an inverse times its a matrix times its inverse gives you its identity matrix. So let us use determinant. Find the inverse of a matrix using determinant. This is something you have done. The determinant of A equal to AD plus AD minus AD CD. And it is so the inverse of the matrix, the inverse of this matrix is just given by 1 over the bracket. You exchange these leading diagonals, then you multiply the second diagonal by negatives. So for our matrix A, we just do that. Yeah, for the 2 by 2 matrix, it's very easy. But when it comes to 3 by 3, it's not easy to get to use the inverse, to use the determinant. So that is why we go to row reduction. One over the determinant. Determinant of A here is just A, 4 times 1 minus 3 times 6. Exchange the first diagonal, multiply the second one, then you multiply this scalar multiplication, that times that will give us minus 2. This times this will give us 1. That times that will give us 3 over 2. This times this will give us minus. These are the same thing we got up for. So, same as that one. Using row reduction and using determinant, you're getting the same answer. So we're going to use row reduction. And what we do here, we'll just do it on the other side. Normally here when we are looking at, when we get the determinant for, no, the inverse for the method in which you use determinant, we always get the inverse, then we multiply with this matrix, we get the identity and multiply the inverse here. That here you're left with xy, which will give you the answer. But in draw reduction, as you reduce this side, like you've seen, you just reduce getting your answer because you're multiplying this one by the inverse. Okay, so we are just applying the way we were taking 1001. Now we are reducing this to 1001 and that one. So we have 3, 4, 7. So we just want to reduce this to look like 1001. What does that is it's inverse, and because we are reducing it to using it to even this one will use the same way. Because here, as I've said, for you to get xy, you must multiply this side by the inverse of this matrix and this side. Because in mathematics, we lose nothing. You're multiplying one side by the inverse and you must multiply the other side by the inverse for you not to change that equation. And once you multiply this by its inverse, you get an identity matrix. An identity matrix by any matrix, you just get xy. And this side, you get your answer. So here we'll just do the same thing. We want 1. We just take R1, take R1 minus R2. 3 minus 2 will give us 1. 4 minus 7 will give us minus 3. 10 minus 11 will give us 10 minus 11 is what? 10 minus 11 is
-1.
we want 0 here. Remember, we want it to look like an identity matrix, so we want 0 here. So we will take R2 minus 2 R1. Because you've seen R1 is 1. Two minus 2 times 1 is 0. R2, 7 here, minus 2 times this one. 2 times that is 6. So 7 minus this is 13. Is a negative here. So, and this one you're multiplying 2 times R1. R1 is negative, and there's a negative. So you have 7 minus 6. The same thing we do here. R2 is 10 minus 1 times 2, which is minus 2. So that will give us 13. That is 11. one did not change. This one changed, but this one did not change, so this is 11. So we have R2, which is 11, minus 2 times R1. 2 times R1 is 2 times minus 1, which is 2. So you have 11 minus 2, which will give you 30. So we want 1 here because we want this to look like an identity. Therefore, we'll just take R2, divide by 13. This is 1. We're dividing everything. 0 over 13, 13 over 13, 13 over 13, that gives you that value. You want 0 here. Once this is 1 and this is 0, you can always get. That's why we take that direction. So always look at that viability. This one is just R1 plus 3 R2. Because you've seen this is a negative and this is a positive. You need to get 0, which you want. This one, we are through with them. Because we've already gotten 0, 1. So this one here, to get this value, you have R1 minus 3 R2. 3 times 0 is just 0. So you have R1, which is minus 3, plus 3 times R2. R2 is 1. So you have minus 3 plus 3, which gives you 0. R1 minus 1 plus 3 times R2, which is 3 minus 1 plus 3 gives you 2. So your x is just 2 and your y is 1. Get to know that your solution is right. Always substitute into your equation to see if it satisfies both equations. That will tell you what you got is right. You don't need to check the inverse. Just check 3x equals to 10. Here, if you put 2, that is 6. Put 1, 6 plus 4 is 10. Here, you put 2, 2 times 2 is 4, plus 7 times 1 is 7. 4 plus 7 is 11. So it satisfies that. It's a solution to it. So I'll give you one, you go and try. And when you meet, you will tell me, you present that it is in 3 dimensions. So you have all the tools that you can use to do this. Can you, next time we'll have you presenting these results. We can stop there. I hope you've copied. You may copy. Let me share.
No,
bado.
please. Bado hatuja.
Have a nice evening.